Hi everyone, today we are going to start 12.1, which is find probabilities and odds. The first example here, we're going to talk about a sample space, and a sample space is just listing out all the possible outcomes in a situation. So for example 1, we flip a coin and we roll a number cube. How many possible outcomes are there in the sample space? List the possible outcomes. An easy way to kind of figure out what the sample space is by using a tree diagram. So we first flip a coin. So there are two possible outcomes of that, either heads or tails. Next, we roll a number cube. Well, there are 6 possible outcomes for that because there are 6 sides of a number cube. So that means that there's going to be a total of 12 possible outcomes. And so here they are listed below. So we have H1, H2, H3, H4, H5, H6, P1, T2, T3, T4, T5, T6. So a total of 12 outcomes. So let's try this again. Now we're going to flip 2 coins and roll a number cube. How many possible outcomes are there in this space total? All right, well, if we flip 1 coin, our possible outcomes are head and tails. If we flip another coin, once again, it's going to be heads or tails. But we also have that number cube, so we have 6 possible outcomes there. So let's see how many total outcomes we have. We have HH1, HH2, HH3, HH4, HH5, HH6. And so that pattern keeps going. And I actually listed them all out here for you. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible outcomes. And there actually is an equation to this. If you don't want to draw the tree diagram, an easy way is to say, okay, we flip a coin. How many outcomes are there? 2. All right, we flip another coin. How many outcomes are there? 2. Finally, we roll a number cube. How many outcomes do we have there? 6. Well, what is 2 times 2 times 6? 24. And this will work for any type of situation. So once again, if you don't want to draw out the number or the tree diagram, you can multiply the total number of outcomes and they will equal your sample space. Probability. The probability of an event is the measure of the likelihood or chance that it is to occur. Probability is the number from 0 to 1 and can be expressed as a decimal, fraction, or percent. So if we have a probability of 0, that means it's impossible, it's not going to happen. A probability of 1, that means it is certain, it is going to happen. And then we have everything in between. Theoretical probability. Theoretical probability is what should happen. So it's the outcomes for the specified events are called favorable outcomes. When all outcomes are equally likely, the theoretical probability of event can be found using the following. So this is our equation we're going to use. So theoretical probability, number of favorable outcomes, what you want to happen, divided by the total number of outcomes. And we write probability as P of A, so the probability of event A occurring. So here's our first example, t-shirts. You and your friends design t-shirts with a silkscreen emblem, and you are selling the t-shirts to raise money. The table below shows the number of t-shirts you have in each design. A student chooses a t-shirt at random. What is the probability that a student chooses a red t-shirt? So to figure this out, the probability of red grabbing a red t-shirt, we first need to figure out what is the total number of red t-shirts. Well, if we look at our diagram here, we see that there are 6 red t-shirts with gold emblems and 6 red t-shirts with silver emblems. So that means that there's a total of 12 red t-shirts. Well, what's the total of t-shirts altogether? Well, 10 plus 8 plus 6 plus 6 is 30. Now you can simplify this if you want, but I would accept this as an answer on the homework or on the quiz. But this does simplify to 2/5. All right, same problem here, but just different questions. So what is the probability that a student chooses a t-shirt with a gold emblem? All right, well, let's figure out what is the total gold emblem t-shirts here. We have 10 and 6, so that is 16 over the total number of t-shirts, and we already talked about that that was 30. So you can keep your answer like that, or you can simplify, it's up to you. So this does simplify to 8 over 15. All right, and then this goes back to tossing a coin and rolling a number cube. What is the probability that a coin shows tails and the number cube shows 4? Well, let's figure out first what is the total number of outcomes. So tossing a coin, there's a total of 2 outcomes. Rolling a die, 6 outcomes. So we know that there's 12 total outcomes. Well, how many times can you land on tails and the number cube show a 4? That's only 1 time. So our probability of that event happening would be 1 out of 12. And you can draw a tree diagram if you want to see that in detail. The last thing we're going to talk about is experimental probability. So an experimental probability is based on repeated trials of an experiment. The number of trials is the number of times the experiment is performed. So each trial in which a favorable outcome occurs is called a success. So here's our second equation. Experimental probability is the number of successes divided by the number of trials. So what actually occurred? Example 3. Each section of a spinner shown has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? Well, we have to think about what was theoretical probability. Theoretical probability is what should happen. So if we look at our spinner, we notice that we have 4 colors: blue, yellow, green, and red. Well, each of these pieces on the spinner are the same size, so they have the same probability of the spinner landing on that color. So the theoretical probability is 1 out of 4. 1 out of 4 chance that it's going to stop on either blue, yellow, green, and red. Now here's the experimental probability. This is what happened when someone actually spun the spinner. So we want to see which one of these is going to equal 1/4. So let's start with the probability of red. Well, we see that it landed on red 5 times. Well, what was the total number of spins? Well, 5 plus 9 plus 3 plus 3, that equals 20. All right, let's move on to green. We see that green, it was 9 times, and we spun the spinner 20 times. Blue, landed on blue 3 times. We spun the spinner 20 times. And then finally yellow, it landed on yellow 3 times, and we spun 20 times. Well, 1/4. None of these say 1/4, but if you look at red here, we see that this does simplify. So 5/20 does simplify to 1/4. So our answer is going to be A here. The theoretical probability, what should have happened, is the same as the experimental probability.